Today I will discuss about capacitor. Basically, capacitor is a device that used in electronic circuit. So, see, capacitor. So, how we can make this capacitor? So, for that, we need two conductors that separated by a dielectric or an insulator or vacuum. That means whenever we wanted to see the net charge on these two conductors, that would be zero. Why it is zero? Because one conductor carry positive charge and the same amount of negative charge that carry on the second conductor. And as we discussed that these two conductors right now separated by some distance. So you supposed to be the distance is d. So how we can make? First of all, you see about this that it is a device that used in an electronic circuit that made by two conductors separated by either a dielectric and insulator or vacuum. That means this capacitor basically it is a device that used in an electronic circuit that made by two conductors separated by either dielectric or vacuum. That is called insulator. So to form a capacitor, there are two conductors. Suppose one conductor having charge plus Q. So the second conductor having the same amount of negative charge. So what happens that this conductor reflects its electric field lines. So what happens because the charge is spread on its surface that is positive. So electric field lines that emerges out on the surface of this conductor perpendicularly outside. So like that. And because this conductor having negative charge, so the electric field that came from infinite on its surface and that would be also perpendicular. So in this direction. Now because this one is spherical, so field lines be like that. Field lines be like that. You can see. From the surface to the infinite for positive charge, and for negative charge from infinite to the surface of this charge. Suppose this positive charge we have given on the surface by using some external source, like this one is EMF having a potential difference VAB. So this conductor get charge. Suppose Q be the charge that given by this uh, potential difference, that is this one is actually this one is a EMF. So using this one. So what happens actually, here we want to find the capacitance by using these two conductors. So simply you can find that capacitance of these two conductors be charged by potential. So the potential between the two conductors is just like the potential of this EMF, that is VAB. So this one is the capacitance of these two conductors, and by this method we can make a capacitor because there is a separation between the two conductors. So basically what it does, conductors that store electrical energy in an electric field in the form of charge. That's why it is called device. So why it is called device? Because capacitor that stores electrical energy in an electric field in terms of charge. So actually a new term that comes, this is called electrical energy. Yeah, electrical energy that is stored in this capacitor. But how it is stored there? Due to this electrical, this electric field. By this electric field we store electrical energy in terms of charge. That means you have to integrate to find the capacitance of this capacitor. You have to integrate the electric field. So there is a relation in between potential and electric field. So according to relation between electric field and potential, V is equal to EDR. So basically ER is a small distance between the separation. So at any instant, so suppose its separation be R, and we want to find at a distance R from one conductor. You have to just take a small separation. So suppose this separation be dr at a distance r from A, because this one, this terminal left side you can just say A and this one is B. Why? Because this one having potential A and this one having potential B. So VA is at higher potential because it is connected with positive terminal, and VB is called negative potential. Why? Because it is connected with negative terminal. So you can say this one VA and VB. So from A at a distance R, you have to consider a small distance dr. So what happens? Because your electric field in this direction, so there is a relation that E dot dr of integration with a negative sign, because the relation between electric field and potential is V is equal to minus E dr. So accordingly, and now you have to integrate this one. So from where you will integrate? From B to A, because A is at higher potential and this one is at lower potential. So we are going in opposite direction. That's why we have taken a negative sign here. And this one is A, B. Why? Because VA minus VB. VA is at higher potential and VB is at lower potential. So accordingly, VA minus VB is written as VAB. Accordingly, whenever you will integrate this one E dot dr, so what happens? Whenever you will take it from A to B, so that would be negative. So you just take a negative sign and you take reverse of its integration, that is B to A. So you will get the same resultant. Now finally you have got the potential between the two conductors. Right now you have to find the capacitance in terms of electric field lines. So we know, you know that C is equal to Q by V. You just take this one is equation 1. So from equation 1, we just find out that C is equal to Q by VAB from equation 1. So from equation 1, now you just put the value and you got that C is equal to Q by, and put the value of VAB from this equation. So this one is minus integration of B to A E electric field lines dot dr. So this one is your result. The second point is that how we can represent the capacitor. So basically this capacitor is represented by two parallel lines like that. So just see note 1 that capacitor is represented by two parallel lines like that. You have to just draw two parallel lines, and from both of the parallel lines you have to take two perpendicular lines like that, and you can say this one A and this one is B. So this one is called terminal A and this one is called terminal B. So this is the way of representation of capacitor. Next point is parallel plate capacitor. In same way, you have to take two conductors, but the shape of the conductors be parallel, just like a plate. So see, there is a two parallel plate like that, and if you wanted to give, suppose positive charge q with a positive charge plus q, so what happens? This positive charge will be distributed on its whole surface. So there is a two faces of this plate. One is at right, another one is at left. You just see there is a positive charge that is distributed uniformly on its surface, as well as negative charge be also distributed on its surface. So this positive charge distributed on both of the faces of this plate. Suppose the area of this plate be A. So A is the area. But whenever you will connect its other faces to a external source, just like EMF V with the potential difference of this EMF. So what happens? A and its one is at B. So what happens? The surface, that is the left face of this plate, is connected with this wire. So this charge will not reflect on its left face. Similarly, on its right face, this negative charge will not reflect because that is condensed in this wire. Like that, this positive charge will condensed in this wire. This one is the direction of conventional current. So what happens? Electric field in the left side of this parallel plate capacitor be 0 magnitude. Its magnitude is 0. Similarly, its magnitude on the right side of this plate be also 0. So what you have? You have electric field on the right face of this plate A and on the left side of this second plate. So electric field that emerges out perpendicular to the plane of this surface like that. You say E1 and emerges in the left face of this plate. You just supposed to be E2, whereas E1 and E2, magnitude of E1 and E2 both are same. So we just write down here magnitude of E1 is equal to magnitude of E2. You must say E. And if this one separated by a distance d, then I wanted to find capacitance of this parallel plate capacitor. So first of all, we need to calculate how much is this electric field, because so if you have studied Gauss law, from there you know that E dot ds is equal to q in by epsilon naught. So actually from there your electric field that depends on charge and the faces from which the field lines be reflected. So in actual, what happening that whenever you have given this charge to this plate, so the same charge will be reflected as an electric field on the left face and on the right face. But we are using one face only. Why? Because the other face be connected to the wire with this EMF. And same thing with here. That's why by using Gauss's law, your E1 that would be half of sigma by epsilon naught. Now here you have to understand what is sigma. Sigma is the surface charge density, and surface charge density is the charge per unit area. So for this plate you have charge plus Q, so your surface charge density be sigma, and this one is also sigma but minus sigma, and this one is plus sigma. Now here sigma with the surface charge density, so sigma is Q by A. You can say this one is equation 1, equation 2, where sigma with the surface charge density. We will use this one. So using Gauss's law, you just find out fill lines. So your E will be, now from here, what you see that your E in this direction, E1, just see, E1 is equal to sigma by 2 epsilon naught from left to right. Now for this plate, your E2 will be magnitude of E2 sigma by 2 epsilon naught in this direction. So finally, E is equal to magnitude of E is equal to E1 plus E2. Now put the value from here. Your E1 is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So sum of this one, your electric field lines between the plate, between the parallel plates, that would be sigma by epsilon naught only. This is your equation 3. Now you got field lines between the parallel plate capacitor. You just find out the potential. So now your potential is, using the relation between the electric field and potential, we just write down using the relation between electric field and potential. V is equal to ED. This one is your potential, E electric field, D is the separation between the plates of the capacitor. So from this equation, from equation 3rd, your electric field is sigma by epsilon naught, and this one is D. Now put the value of sigma, because sigma is the surface charge density, and surface charge density be always Q by A, that is charge on the plate by area of the plate. So from equation 2, we just put there the value of sigma Q by A epsilon naught into D. Now this one is your equation 4, and then you find the capacitance. Therefore capacitance of the parallel plate capacitor, that would be C is equal to Q by V. Now put the value. Your Q is Q and V from equation 4. Just put this value. So this one is Q by epsilon naught A into D. This Q and this Q will be cancelled. Denominator of denominator will come on numerator. Therefore, your C will be epsilon naught A by D. This is the capacitance of a parallel plate capacitor. Now from here, what we are seeing, that this capacitance that depends only on the configuration of the capacitor. Why configuration? Because this epsilon naught with the permittivity, it is constant. D is the separation, that may be anything. So finally your capacitance that depends on the surface area. So that depends on different bodies having different surface area. That's why your parallel plate capacitor is directly proportional to the area of the plate and the separation between the plates. That means from here, that is C is proportional to A by D. 5 and this one is equation 6. So C depends on configuration of the capacitor in case of parallel plate capacitor. One note be there. To make a parallel plate capacitor, here we need a two parallel plate. By using two parallel plate, we can make one capacitor. So suppose if you have n number of plates, then the capacitor whose capacitance that will be C is equal to n minus 1 epsilon naught A by D. So your capacitance that will be n minus 1 epsilon naught A by D. That is one less by number of plates.